In section 2.7, we are going to learn how to graph piecewise defined functions, and then we will figure out how to test for symmetry and even or odd functions. A piecewise defined function has a different rule over different intervals of its domain. So if I'm looking at this rule here, f of x equals negative 2x plus 5 if x is less than or equal to 2, and x plus 1 if x is greater than 2, that means I'm going to have two different graphs on my coordinate plane at the same time, but they can't overlap. If they overlapped, then it wouldn't be a function. So we have to pay attention to a couple of things. One being whether the boundary is going to be an open or closed circle. And the way we tell that is by looking at the rule, like where the domain breaks. So if it is a less than or equal to, then we are going to have a closed circle on that boundary. If it is just a greater than or less than, it will be an open circle. So when x is less than or equal to 2, so for all of these numbers, less than or equal to 2, we are going to be following the rule y equals negative 2x plus 5. So we should know what that graph looks like. Y equals negative 2x plus 5 is a line that has a slope of negative 2 and a y-intercept at 0, 5. So on the interval, when x is less than or equal to 2, so all of this part of our graph, we're going to put that line. So I'll go ahead and put my y-intercept at 0, 5 right there. And then use a slope of negative 2, so down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1, and get a bunch of points on there. But then I can't go past this green boundary. So these little dots that I added here are going to be ignored. What I'm going to do is draw the line up until I reach the edge of that x is less than or equal to negative 2. I'm going to put a closed circle on the boundary. So I'm going to have a closed circle right here. And then I'm going to connect the rest of my dots. If I had a straight edge, there it is. Connect the rest of those dots. Put an arrow because it's less than or equal, so it goes forever. And then where my rule changes, I'm going to follow the rule y equals x plus 1, which is also a line that has a slope of 1 and a y-intercept at 0, 1. So I'm going to put that on the interval when x is greater than 2. So that's going to go on this part of my graph. So I'll put my y-intercept at 0, 1. And then follow a slope of positive 1. So over 1, up 1, and I keep that slope going. But notice that the dots I'm putting over here are in the green zone. So I'm not going to draw that line in the green zone. I'm only drawing that line in the orange zone. So I won't start until right here. But at the boundary, I have an open circle. So this dot is going to have an open circle right there. And then I'll connect the rest of these dots that are in the orange zone and make my graph look like this. So that's what that piecewise defined function looks like. Let's look at some more examples. F of x equals 2x plus 3 if x is less than or equal to 0, but negative x squared plus 3 if x is greater than 0. So when x is less than or equal to 0, that means I'm going to have a closed circle on the boundary for this graph when x is less than or equal to 0. So here's my green zone. And I'm graphing the line y equals 2x plus 3 that has a slope of 2 and a y-intercept at 0, 3. So I'll put my y-intercept at 0, 3, use a slope of 2, up 2 over 1, up 2 over 1. But notice that I am getting out of the green zone over here, so I'm not going to connect any of these dots that I just put. I'm only going to start graphing on the boundary of 0. And that one is going to have a closed circle. So I'm going to have a closed circle right there. And then I'm going to connect the rest of my dots that do fall into the green zone like that. So the green zone broke at 0 and went that way. The orange zone is when x is bigger than 0. So that is going to be a parabola, like y equals x squared, but it has some transformations. It is shifted up 3, and it is reflected over the x-axis. So instead of this parabola starting at 0, 0, it is going to shift up 3 and start at 0, 3. And instead of going over 1, up 1, over 2, up 4, when we reflect over the x-axis, these actually go down 1, down 4. And same thing, left 1, down 1, left 2, down 4. So I'm going to start at 0, 3, 1, 2, 3, and it has an open circle. Well, notice at 0, 3, I already have a closed circle. So I'm just going to put the open circle right around the closed circle, like that. And then I'm going to follow my pattern where I go to the right 1, down 1, to the right 2, down 4. And then left 1, down 1, left 2, down 4. But these points are in the green zone, so I'm not going to draw them, only drawing the ones in the orange zone. So I'm going to draw just half of this parabola, and it is going to look like that. Oh goodness, this one has 3 rules. Now I have 3 zones. I've got 3 zones. I have x is less than negative 3. So that's going to be here because it doesn't include negative 3. So less than negative 3, that's over here. Then I have when it's between negative 3 and 2. So between negative 3 and 2. And that's going to go between negative 3 and 2. And then I have greater than 2. So that's going to be my green zone. So in the blue zone, I am following the rule y equals negative 2x. That is a line that has a slope of negative 2 and a y-intercept at 0, 0. At the boundary, it's going to have an open circle. So I'm graphing starting at 0, 0 with a slope of negative 2, down 2 over 1, down 2 over 1. But notice that I can't draw any of these points that I just put on there because they're not in the right zone. I can only start drawing these points when I get into the blue zone, which is right here. And at the boundary of the blue zone, I need an open circle. So I'm going to put an open circle right there, and then I would only connect the dots that are in the blue zone. So that's the only part of that line I'm going to draw. In the orange zone, I'm following the rule y equals 3x minus 1, which is a line with a slope of 3 and a y-intercept at 0, negative 1. So I'll put my y-intercept as 0, negative 1, use a slope of 3, it's a positive slope, and then I've got to decide about open and closed circles. Both of these are the less than equal to, so I'm going to have closed circles on both boundaries. So the boundary here between blue and orange, I'm going to have a closed circle right there. And then the boundary between the green and the orange also has a closed circle right there. And then I only connect the dots that are in the orange zone. So these are going to be This is going to be the only part of that line that I graph. And then I have the green zone. The green zone is the line y equals negative 4x. That line has a slope of negative 4 and a y-intercept at 0, 0. And at the boundary, I'm going to have an open circle. So I'll put my y-intercept at 0, 0, use a slope of negative 4, 1, 2, 3, 4, over 1. 1, 2, 3, 4, over 1. 1, 2, 3, 4, over 1. But I'm only going to start drawing at the boundary between orange and green. So that is right here. And it has an open circle. So we get an open circle and then connect those dots. So that's what that graph would look like. Now to evaluate function values, then what I need to do to figure out f of negative 5 is figure out which zone negative 5 is in, because that's an x value. So x equals negative 5, would that be in the blue zone, the orange zone, or the green zone? X equals negative 5 is right here, which is in the blue zone. So I'm going to be following the rule y equals negative 2x. So that's where I'm going to substitute negative 5 into. So f of negative 5 will be negative 2 times negative 5, which is 10. Now what about f of 0? 0 is in the orange zone. So the rule that's going to be followed is y equals 3x minus 1. So when I substitute in 0, I'll do 3 times 0 minus 1, which is negative 1. f of 2. 2 is right on the boundary. So I need to figure out which one owns the number 2. So that's going to be the one with the closed circle. So I can visually see on the graph, there's my closed, there's my open, so it belongs to the orange. But if I don't have a graph, I'm going to look at my boundaries. 2 is included in this boundary, so it is going to be following the orange rule of y equals 3x minus 1. So I'll substitute 2 in for x, so 3 times 2 minus 1, which is 5. f of 5. 5 is way over here. It's in the green zone. So I'm going to be following the rule y equals negative 4x. So substituting 5 in for x, I get negative 4 times 5. So that answer would be negative 20. All right, let's look at the domain and range for this piecewise defined function. The domain, we're going to go left to right. So looking at the domain, the first thing that I run across in this graph is an arrow. Remember that arrows represent negative infinity or positive infinity. Since this one's on the left, it is going to be negative infinity. Then when I get over to 0, it looks like I have a missing value, but notice that there's also a closed circle at 0. So technically, does it go negative infinity to 0 and then start back up with a closed at 0 and go to infinity? Technically, we could write it like that, but because there is that overlap at 0, we wouldn't write it that way. We would write it negative infinity to infinity because there are no x values that are skipped over or left out. Now let's look at range. Range, when we go bottom to top, we have the value of negative 3. And it's a horizontal line, so it's just a single value of negative 3. And then we have a skip, and we start up again at 0, which is including 0. And then we end with an arrow, so it ends at infinity. So for the range, we have negative 3, which is a single value. And the way that we write that is to put it in curly braces. So the single value negative 3, and then the interval starting at 0, ending at infinity. And since that is a closed circle, it will be a bracket at 0. Where do we have a discontinuity? In other words, what x value do I have to pick up my pencil if I'm tracing from left to right? So as I go left to right, negative infinity, all the way to -4, -3, -2, -1. Right here when I get to x equals 0, I have to pick up my pencil and move it to here to keep tracing that graph. So I have a discontinuity at x equals 0. What is f of -2? F of -2 means what is the y value when x equals -2? That's what that question is asking. So if I find -2 on the x, where is the graph at? What's the y value? Well, it's down here. And the y value would be -3 on that line. So f of -2 would be -3. What about f of 0? So that's asking what's the y value when x is 0? So find where x is 0. There are two places this graph is, but where is the closed circle? It's here. And the y value at that ordered pair is 0. So f of 0 would be 0. And then f of 4, what's the y value when x is 4? So trace along to x is 4. What's the y value? That ordered pair is labeled for us. The x value is 4, the y value is 2. So f of 4 would equal 2. We're going to end here and we'll come back and do another part about symmetry.